right, hi everybody. I'm very happy to be here. Thanks for the intro, Ben, and thanks for the chance to be up here to talk about why ADP is excited about Docker. So let's dive right in. I think to start with, probably most of you have heard of ADP. Should I get a show of hands on that? Yeah, everybody. We have over 630,000 clients, B2B clients that we serve around the world in over 100 countries. We do 5 million logins a day, which is a lot for us to manage and secure. And we have a wide variety of applications that I'd like to show you. So we're known for payroll, and that's where we started. That's our bread and butter. But really, we've broadened out. HCM is in the title there. That stands for Human Capital Management, and that's kind of the name of our category now, where we do everything from recruiting, job websites, and posting boards, and all that kind of stuff, and all the way through to retirement and 401k planning, and thinking about your death and your life insurance beneficiaries, and everything in between, time tracking, absence management, benefits tracking. We actually provide healthcare and manage healthcare for more people than healthcare.gov does. Okay, all kinds of different areas within HCM that we do. So we have a breadth as well as a depth and scale to our offering, and that makes things really complicated for us. So anyway, let's move on. So why, then, do we think Docker is key to our future acceleration? And I think it comes down to that we have been around for now, I think for about 65 years, and we have always viewed ourselves as a services company. We're there to help our clients and kind of offload complexity from them. But now, because the competition is getting so fierce, every company is becoming a tech company. And that technology is the way that companies are measured, whether you're talking about in any industry at all, including in HR industry. And so I think really for us, Docker is a key point of acceleration on how we're going to make our product development process faster and compete better. So let's talk about competition in general. Like, why does Docker matter to competition? And I think if we view this stuff as a race, it's a good way to think about it. And generally, like the drivers of these cars, you know, the executives in a company, the leaders, they have a sense of where they are competitively and what their position is. They know from wins and losses. They know from the word on the street. They're talking to clients. They've got an idea of where they are. Just like it's hard to tell in this picture who's ahead between those two cars, but probably those two drivers know because they're right next to each other. The issue, though, is that in this race, there is no finish line. And when the race goes on forever, the fact of the matter of like who is ahead at this moment is not as interesting as who's gaining and who's losing. What is the speed of those cars? And so speed ends up being the thing we all care about, and momentum. And so let's talk about speed. So in a world where every company is a tech company, the speed of execution of that company comes down to who codes faster. And you know, think of all the untold effort that we've spent over the past 2 decades in trying to code faster. Most of it falls under the heading of agile transformation. And so we started with waterfall development, then we went to extreme programming and pair programming and scrum programming. And we have platform strategies and metadata strategies and drag and drop GUI tools and all kinds of stuff. And it's all about going faster. We've done everything we can think of, except for maybe sending developers to typing school so they can type faster or something. But at the end of the day, that's been good, but it's not enough either. And so coding faster isn't actually the client experience. Who ships faster is the client experience. And so I love this metaphor of the pit stop because I don't know how many of you here follow Grand Prix racing at all for Formula One. There's a hand, a couple hands. Yeah, good. So the Grand Prix of Monaco was 3 weeks ago. There was a guy named Ricciardi who was in the lead, and he had a pit stop that was a disaster because the average Formula One pit stop now takes 1.5 seconds to change 4 tires and refill the car. 1.5 seconds. This guy's pit stop was 5 seconds, and it will be talked about for decades for that extra 3.5 seconds because he lost the race over that pit stop. Okay, so I think that in this world, like the cars cost $30 million and the drivers are celebrities, but the pit crews win and lose the races. And so I think like in our world, we've started to recognize this as we talked about DevOps, and we try to get devs and ops to be friends and to work together, to communicate better, and to go have beers. You know, that's the cliche we always hear, right? We want to shift certain tasks to the left and shift right on other tasks and make everybody work perfectly. But I think actually that is not done enough, and I think Docker actually shows us the way for how we can go to a new kind of DevOps. And so the way I like to characterize this is that there becomes a clean separation between packing the containers and shipping the containers. The transportation business is a different business than the manufacturing business that loads those containers. And so as a result, like the devs can work on things, and the forklifts or your automation tools, I often nickname that forklift Jenkins. You know, so we have ways of filling up the containers, and we get better at doing that. But the ops guys, they have thousands of containers around the world that they need to track and keep and move and do efficiently and stack well and track their state. So they have a clear job, and the common denominator, the handoff point for that, is Docker. And I think it's one of the reasons why Docker has really gone viral in the past 3 years. So this is the potential that we have at large organizations to revolutionize how we ship code. So, you know, I know this is a big room full of people that are already sold on Docker. So I'm not going to go into a big, long philosophical thing about why Docker is awesome. Okay, but you may have guessed from this slide that I have 3 things that seem unique about ADP, or things that are interesting about what we're doing there. So let's dive into those. First of all, we often talk about how, you know, we see pictures of containers and they're always rectangular boxes, all this. This is a special kind of container, though. Not all containers look that way. This is one for nuclear waste. They transport stuff, spent fuel from reactors on these kinds of containers. And I think this fits ADP's metaphor as well. We have sensitive stuff that we're putting in these containers. We have 55 million social security numbers on file, including probably most of yours in this room. Think about it, okay? Last year, we moved $1.8 trillion through the ACH system in America. 10% of the GNP of the country was moved around actually 4 separate times through ADP machines. We are considered critical infrastructure by the US government, and we work with FBI and other 3-letter acronym agencies to actually go after state-sponsored hackers and all kinds of stuff. We have a top 10 most wanted list that we track with the FBI, and we've actually arrested 4 of those people in the last 12 months. We work every day with these kinds of people. Thank you, I love that. We need consequences for these guys. So anyway, security is a huge deal for us. And we consider ourselves a pretty high-value target. And so hardening the containers actually is really important to us. And this goes back to what Ben said about going to containers because we need more security, not in spite of needing more security. And so 3 areas of this that I think are interesting. First of all, this idea that Docker Data Center will only run signed binaries, where we know the provenance of the servers and of all the layers within those images, is important. We need to know that we trust what's in production. The second layer, though, is automated container scanning that's on a more continuous basis. We need to know that what's running now is what we started running before. And if something's been compromised or hacked, then we need to know that by comparing the images to what was originally there. And then third, I think this issue of Docker trusted registries. We use multiple registries at ADP because in the production level, we want the most trusted, most vetted, most stripped down minimal containers that we can get. But if we only have those, then we limit developer freedom to download and to experiment and to find things on Docker Hub that they might want to try. And so to allow them the freedom to experiment, but to also lock down our production environment very much, we've actually created 3 separate repositories. There's a middle stage as well for anything goes. This is what we think we want, and this is what we have that we've totally vetted. And we have a whole process for how we promote in those environments, how we scan and score, and what the thresholds of certification have to be to get to each level. So I think this is an area where ADP has put a lot of work into trying to be sure that we're certain of what's going into production while still giving developers freedom to do what they want to do and to maximize their own productivity. Disparate systems. Okay, I mentioned to you before that we have a broad variety of tools. We have 200 or 300 products that we offer in 120 countries. Most of these are large systems at scale running in our private cloud. I should have mentioned before that of the 630,000 clients, over 500,000 of those clients are running in our data centers. We are our client's cloud. The public versus private, our clients probably consider us to be part of the public cloud. Okay, so all this stuff is running, many different systems running at scale. And so the ripple effects and the way that those systems could interact are essentially, could be a risk for us. So let's talk about how we do this. I don't think it's too earth-shattering, but what we're doing is we're starting small. We start with very small clusters. It's actually multiple clusters for a single product. And so the way we start by scaling is maybe a swarm can handle hundreds or thousands of nodes in theory, but for us, we might start with 10 nodes or 20 nodes and have several of those for a product, and maybe hundreds in some cases. But over time, the clusters will grow, and the swarms will organically take on more and more volume. Kind of like the raindrops on the hood of this car, where as it rains, the drops get bigger, and then eventually the drops touch, and they merge, and then the swarms start to coalesce into bigger and bigger structures. And so as that happens, we will start to have a single swarm for a product, and then the lines between the products will blur. And as the line between the products will blur, the lines between the environments will blur. And that really freaks my security people out as we talk about that. But then you can imagine that we have data center level clusters that are covering our entire data centers and spanning multiple DR kind of data centers. I think the last span for us will be public versus private cloud, where we will have most of our systems internal, but then when we need to scale beyond what we normally would do for peak loads, we might offload that to Azure or to Amazon or to someone else. And there will come a point where I think most of the IT people in ADP that are intensively debating public versus private clouds, in the future, I think most of them won't care, that the swarm will manage it. And there will be a few people who know, but it'll mostly be a financial decision about what we decide to do. And to the rest of us, it will be an abstraction layer beyond which we don't care. So the last area that I like to talk about is microservices. Okay, so everybody agrees that microservices are awesome, don't we? I think so. Once you see them, yeah, there you go. Once you see it in action, you have to have microservices. And it's kind of like chicken McNuggets. Like, everybody loves nuggets, okay? No one wants to gnaw on a bone anymore after you've had a couple of nuggets. So it's like, and chicken McNuggets are convenient. We've pressed them down, they're bite-sized, they're standardized, they're pressed into the same shapes, they all kind of look the same, okay? And so it's great, and it's handy to think about a box of nuggets as your system, and your 20 McNuggets in a thing is your whole distributed architecture, okay? But we don't actually have nuggets, though. Oh, thank you. So we don't actually have nuggets, though, at ADP. Like, we wish we had nuggets. We're working on nuggets, okay? What we have is chickens, okay? So we have monolithic apps, okay, that are all together, and they're cohesive units that all are one thing. And so the chicken, he looks kind of worried, doesn't he, right? He could be nuggetized, okay? But in these products, like, these are large products. I think you've said we're large, right? So some of these apps are millions and millions of lines of code, and they're code that could be a decade old or older. Okay, so what do we do? If we agree that Docker is awesome, and we agree that microservices are awesome, what do we do about our chickens? And so this is where I'm going to switch to a different food and say, we have an ice cream strategy here, okay? We're going to take the tub that the ice cream is in that picture is a container. And the Baskin-Robbins that contains that container has 50 huge containers full of different kinds of ice cream. And if they didn't have those containers separating out the ice cream, they couldn't manage the Baskin-Robbins. But the problem is that the big containers only take you so far. And then what you need is you need small containers called waffle cones, and you're going to scoop out a piece of your small code, and you're going to put it into a separate waffle cone, and that is now your microservice. So what you have then is a hybrid in your applications going forward, and an evolutionary path where your large monolithic systems will get carved up by the ice cream scoop refactor method, and you'll end up with a row of cones on the side and a half tub full of ice cream. There, and the interesting stuff, the stuff that changes a lot, thank you. But the cool part about it is that the stuff that changes a lot is the stuff that will get refactored first. The interesting things and the stuff that's really subject to a lot of activity will be the part that's in the microservices, and that will become the part that's easier to work with the fastest. And the stuff that doesn't change very much and that just works and is there all the time and is invariant, that will be what remains in the big container. And it's waiting for refactoring at a later date if you need it, and if you don't, that's okay too. So this hybrid strategy is how ADP is attacking big containers and the legacy problem of monolithic apps. So anyway, I hope you see with all of those that like Docker and ADP, we have a real strategy. We really know what we're doing on this. And we have a lot of people working to make this happen across the world in our company. We're really excited to be with Docker and to be partners on this. So thank you very much.